All right, let's get started. So task 8 is out. For those of you ready for task 8, I assume most of you are still working on task 7, but I just want to briefly introduce task 8. Oh. So in task 7, you're opening two separate files. You're reading a song ratings file, which is from the ratings app, where we have all kinds of data about the songs that we've rated, added and rated. And we have a movies file, which has the title and cast of a fairly large number of movies. For task 8, you're going to add to that data a third file, movieratings.csv, which is going to be similar to the song ratings. You'll have the title of a movie, the reviewer ID, and then the rating that they gave a song. So we have song ratings and movie ratings all together. And with task 8, it is all going to start coming together. To be able to build, what we eventually want to build here is, and why do I have this like a wall of text? I can't see anything. Top K ratables. So we have songs, which extends rateable, music that extends rateable, and we're going to use what we're going to learn this week, polymorphism, to be able to write a method that works with generic ratables and find the top K list. For example, if K is 10, you call this method with 10 as an input. You're going to get top 10 lists based on all of the ratables, whether they're songs and or movies that are added to the to your media library. So if you call this method, if you set this up to only read a songs file, we can find the top songs for the class using our real data, actual data, to process this and find out something about the class. And you'll find that one person achieved the system and their song is way on top. And we can even mix movies and songs to find the best media. You just want to consume some sort of media, you can find the top songs or movies using this method based on our ratings for the songs and whoever generated this data set for me. I didn't look into the source, actually, of where the data actually came from, like who gave the ratings. I just found like where I got the data from. I know that source. But whoever gave these ratings, what they think the best movies are as well. So that's where we're headed. That's what we're doing in task 8. To get there, we need to learn some polymorphism. So any questions before we get into polymorphism? Questions about anything? I think things are going fairly well right now. After the previous lecture, I just had a few lab issues, just quiz grading issues that, individual things I can address. I don't think there's any large issues facing the whole class, but if there are, let me know so I can fix it. I think most of you are on either task 6 or 7. Some of you are still on 5, which I don't think any of those tasks have anything overwhelmingly difficult, overwhelmingly brand new. Like task 4, there's so much new stuff and so much of it. That was kind of crushing the class. But I don't think there's anything like that in 5, 6, or 7, or 8 for that matter. Then 9 will be just difficult. 9's going to be, I'll foreshadow it a little bit. 9's going to be degrees of separation for movies. Given two actors, how many degrees of separation are there between those two actors in movies? Where 1 degree of separation would mean or is it 0? I think we started at 0. 0 degrees of separation would be they starred in a movie together? Or would that be 1? I'll figure it out before I write up the assignment. That they starred in a movie together, and if they starred with somebody who also was in a movie with the other one, that would be like 2 degrees of separation, and so on and so forth. That's what we want to build. The nice thing about task 9 is it's one method. Degrees of separation, like that's it. And probably a constructor to load in the data to take the movie's array list that you've already written the method to read the file for, and so probably some constructor to take that, like a file name. But then one method, degrees of separation, given two actors, what's their degrees of separation? So it is something we can manage. Wait, that's not what I was saying. So it is just one method. It's a nice clean description. This is what you need to do, and then actually doing it is just a little difficult. I don't think overwhelmingly so, but it's more difficult than the other tasks in the course. But it's very clear what you have to do. Just getting it done is kind of tricky. Whereas task 4 was just there was a lot of stuff, and getting it all done was stuff. So it's a different type of difficulty. But anyway, Jesse, nobody asked about task 9. All right, so let's talk about inheritance. We talked about inheritance 3 weeks ago plus spring break. So it's been a while, so let's just refresh on what inheritance is, because we need inheritance to use polymorphism. There is no polymorphism without inheritance. So let's recall what inheritance is, just to make sure we're on the same level, the same starting point. So we have this game item class, defining some state and behavior, and then we have a weapon class and health potion class that both extend game item. And when they extend game item, they inherit all of the state and behavior from the game item class and take it as their own. So this X location, Y location, the constructor, and this use method are all inherited by weapon and health potion, just like all of this code were in these classes. And the any inherited behavior that we don't want, we use the override keyword. We said, this use method that I inherited, I don't want this use method to do this thing. The use method has to exist, but I'm going to override its definition to do this. And our annotation, we said, is optional. I prefer it. Paul never uses it. You can make up your own mind and decide what the best way is, but using the override annotation is the best way. So we can have this override annotation, but without this annotation, this code still does the same thing. And then we have to call the superconstructor. The superconstructor, I got to be careful with the way I word this. The superclass constructor must be called in all of the subclasses. If you don't explicitly call it like this, if you don't have this line at all, then you implicitly get a superclass constructor for the constructor that takes no parameters. So super, open paren, close paren, semicolon, that's what you implicitly get if you don't add any superclass constructor call. And if your superclass doesn't have a constructor that takes no parameters, which is the case here, you'll get an error. It'll say, there's no constructor that has no parameters. What are you doing? So in this case, it's not optional. We have to explicitly have the superclass constructor because it takes parameters. But if it didn't take any parameters, we could exclude it. So that's most of inheritance that we talked about in one slide. I don't know why my health potion class got so far over there. And we talked about type hierarchy with this. So we have the visual. I don't remember if I did the visual during inheritance week, but weapon extends game item and game item extends object. And we can draw these arrows pointing to the class that's being extended or being inherited from. So weapon extends game item extends object, which means the weapon class has all of the state and behavior of all three of these classes. Everything defined in weapon, everything that inherited from game item, it has all that state and behavior. And game item doesn't explicitly extend any class, which means it implicitly extends object. So game item, or any class that doesn't say extends whatever, always extends the object class. So by definition, or by extension, I guess, every type in Java, either directly or indirectly, extends the object class. Weapon indirectly extends the object class. So weapon does get all the state and behavior from object, but it gets it indirectly through the game item class. We call this an ISA relationship. This vocab, not too important, but I think this vocab helps explain the concept a little more. You won't be asked about ISA on the quiz. For example, if somebody says, what's the relationship between game item and weapon? the TA is not going to expect you to say is-a. It's an is-a relationship. So you don't have to memorize that term. You have to know the concept and understand this concept. But the vocab you don't have to know. I'll just tell you that straight up. Because Paul won't even say is-a in his lectures. He refuses to. So you won't be asked about it on the interview. But the is-a relationship, a weapon, if it extends or inherits from another class, we say that it is that class. In a very real sense, a weapon is a game item. If I have a weapon in my game, in this game that we're building, I would say that that weapon is a game item, and that weapon also is an object. It really is those things. So it has three different things that it is. This is a very similar relationship in geometry. We say that a square is a rectangle. It has all of the properties of a rectangle. And then it also has some extra properties that make it a square. The same thing is true here. A weapon has all of the properties, or state and behavior in our case, of a game item. And then it also has some extra state and behavior. It has this get damage method, and it has this damage instance variable. It has a new constructor, and an overridden use method. So it has extra things that it's adding to the game item class, but it does have everything from the game item class. It is a game item. And it is an object. Polymorphism, if an object is a type, it can be stored in variables of that type. It's where we cross the line from inheritance to polymorphism. So if I have an object of a certain type, and it is another type, I can store it in variables of that other type. That's what polymorphism is. That's it. The whole thing. We can just end this week right now and say, there you go. That's it. That's polymorphism. So your first question on the interview, when you have your polymorphism interview next week, and the TA will probably start with a question like, what's polymorphism? You should all get this. This is what polymorphism is. You'll say something like this, hopefully not too memorized. If you do just memorize this, they'll get you on the follow-up questions. The follow-up questions will be a little more in depth and talk about the implications of this. But this is polymorphism. That's it. This is it. Anything that's not this isn't polymorphism. And the reason I'm spending so much time on this slide is, and I'll flash it back a few times even, is the difference between inheritance and polymorphism. It's easy to mix them up and see them as one big OOP topic. It's all object-oriented programming. What's the difference between them? I want to make sure that distinction is clear. What's inheritance and what's polymorphism? This is polymorphism. Everything else is inheritance. All the extends, the overrides, when we talk about abstract classes and interfaces and abstract methods, all of it's inheritance. This is the part that makes it polymorphism, is when we start taking objects of one type and storing them in variables of another type, of a type that isn't their own type. This is polymorphism. A weapon is three different types. So a weapon is a weapon is a game item, a weapon is an object. Polymorphism, if we break it down, poly for many, morph for forms, polymorphism, many forms. A weapon has three separate forms, either object, game item, or weapon, and it can masquerade as any of those three types. I guess it's not masquerading if it's a weapon, but it can masquerade as the other two types. Like this. This is all valid code. This compiles, this runs. This is all legal. So for 8 weeks now, I've been saying Java is strongly typed. If you have a variable of a certain type, it can only ever store objects or values of that type. If you have a variable of type int, it can only store ints. If you have a variable of type song, it can only store songs. If you have a variable of type health potion or weapon, it can only store weapons. I've been saying that for 8 weeks, and for the most part it's true, but we're finally going to start breaking that a little bit. We're going to bend that rule and say, well, actually, if you have a variable of a supertype, it can store objects of any type that extends that type, any of its subclasses. So if I have a variable of type GameItem, I can store my weapon in that variable. It's a legal assignment because a weapon is a GameItem. In a very true sense, it is a GameItem. We can treat it as such. We can store a weapon in a variable of type GameItem, perfectly legal. We can store a weapon in a variable of type object, perfectly legal to do so. We can do all of these things. So we can bend the rules of the strong typing a little bit. And we did bend this rule a little bit. We slipped one of these in there. Paul and I couldn't design around this. We just had to. Our BST takes a comparator as a parameter, but you can pass it in decreasing object. So that assignment was actually polymorphism because we couldn't figure out a better way to design that without creating a new BST for every possible comparator. It'd be a pain. So we did use a little bit of polymorphism so far. We just snuck it in real quick. Hopefully nobody noticed too much, because now we want to talk about polymorphism for real. So if an object is any type, it can be stored in variables of that type. So I have this 3 different weapons, which could be the same weapon even. I could do GameItem weapon 2 equals weapon 1. We can talk about the implications of that as well. But weapons can be stored in any of these 3 types, variables of these 3 types. But what's the implication of this? What does this mean for us? And I promise you, I'm going to tell you polymorphism is great. I'll tell you right now, polymorphism is great. This gives us a lot more flexibility, a lot more options with our code. We can make design much better programs, programs that are easier to expand, easier to add new features. Just a lot we can do with this. But I'm going to be a terrible salesperson here. I'm going to start by telling you a big downside of polymorphism. So there's one big downside of polymorphism. When you store a variable, when you store a value, in this case a reference to a weapon object, in a variable that doesn't match its type, you lose functionality. There are certain things you can't do. So when you have a variable that stores a value, you can only access state and behavior, in this case methods. You can only call methods that are known to the class matching the type of the variable. The variable determines what methods are allowed to be called. So this is a pretty big restriction. If I have my weapon, like this is a legal assignment and all, but when I store my weapon in a variable of type GameItem, I can only call methods known to the GameItem class. So this getDamage method, which is defined in the weapon class, it's only known to the weapon class. It can only be called if you're storing your reference in a variable of type weapon. So weapon1.getDamage is perfectly fine, but weapon2 of type GameItem doesn't know about the getDamage method, and this method would not compile. If I tried to call this method, my code would be broken. Doesn't work. Can't do it. GameItem doesn't know about the getDamage method. Can't do it. Pretty big restriction. Likewise, weapon 3 of type object, can't do much with that. Can't call getDamage for sure because the object method, the object class doesn't know about the getDamage method. And in general, classes don't know about the classes that inherit from it. The GameItem class, for all it knows, nothing extends it. There's nothing in the GameItem class that says, hey, by the way, you're extended by this weapon class and this health potion class. Just thought you should know. There's nothing of the sort. It doesn't know. To the object class, it's the only class that exists in Java. It doesn't know about anything else. It doesn't know there's this whole language with array lists and health potions and hash maps and integers. It doesn't know about any of that. It just knows that it exists. So calling getDamage from GameItem that doesn't know about the weapon class doesn't work. And this applies to the whole type hierarchy. No matter where you are in the hierarchy, if that object knows about the method being called, then it can be called. So the use method is defined in the GameItem class. So I can call that through a variable of type GameItem, perfectly fine. GameItem defined the method. Of course it knows about it. And it can be called through the weapon variable, because weapon inherits use from game item, so it definitely knows about the method as well. So both of these types know about the use method. You can call the method through those two variables, but the object class doesn't know about the use method, so this still doesn't compile. Yes, you can, but you don't want to. So can you write methods that take objects as a parameter instead of specifying? Yes, but it's not super useful. And this is why. So if you have a variable of type object, you can only call methods known to the object class, which isn't super useful. What are you going to do with that object? You can convert it to a string with toString. You can call .equals on it, and hope that the equals method is overridden by whatever you have, so it actually does something meaningful. You can get its hash code. There are a few other methods. You can clone it. There are a few other methods in the object class that you can use, but nothing really that useful. ToString might be the most useful one in there, because you can always count on it doing something, where .equals isn't always going to give you something that you want. So you can. Perfectly legal, usually isn't super useful. But you could, like every object, aside from primitives, everything I'm saying has the exception of except primitives. But everything can be stored in a variable type object. So all throughout your code, you could have every variable be type object. But you might not be able to do what you want to do. Like if you create a new array list and store it in a variable of type object, you can't add elements to it. You can't ask it for its size. You can't get elements out of it. You can't iterate over it in a loop. You can't do anything with it, because all you can do is convert it to a string, get the hash code, a couple other things. Check if it's equal to another object. Not much you can do with it. But it is legal Java code. So the variable determines what methods can be called. But when that method is called, the type of the object determines which method is called. And this is probably the most nuanced point. This might be one of the trickier things with polymorphism. The type of the object determines which method is called. The type of the variable determines which methods can be called. What does that mean? So the type of the variable, that's what we're talking about here. We can only call methods known to the variable type. But when the method is actually called, we go to the type of the actual object on the heap and ask it, hey, what do you do when the use method is called? So for weapon 1, that's straightforward, the variable type and the object type match. So it's what we've always done. We go to the object, we go to the weapon class, and then look for the use method and see that it's overridden. But the same thing happens when we say weapon2.use. It's actually the same procedure. So the type of the variable determines if this is legal code or not. Can we call this method or not? Once the variable says, yeah, you can do that, that's it. The variable's job is done. And then everything else is just like we did with the inheritance. We go over to the heap, we find an object of type weapon, and at that point, as soon as we follow that reference over to the heap and find a weapon, we forget about polymorphism. We ask the weapon class, hey, the use method was called. What do you do when the use method is called? It says, well, I'm a weapon. So we go to the weapon class and look for a use method. We find the overridden use method and call the overridden method. So the overridden methods will still be called when we call a method, no matter what the type of the variable was, as long as the variable allows that method call. So when we go to the object weapon 3, this one we can't even call it. But once we call it, everything is as it was. We go to the heap, we check the type of that object, we go to the class for that type, and then call that method. So we lose some functionality, but we still have that functionality. We still have weapon-specific things that we can use. We just have to make sure that the game item class knows about those methods' existence, not necessarily their definitions, but it has to know that those methods exist. And then if they're overridden, we still get the overridden functionality from the weapon class. Probably the most important point in really understanding how polymorphism works. The variable thing, this will matter on your homework when you're calling your methods, just knowing what you have available to you. When you have an object of type rateable, you can't get the ID or the artist as though it were a song. You can't get the cast from it because those methods exist only in song and music. Song and movie. But rateable does have get title, so you can ask it for its title, and you can do all the rating stuff, but you can't do song-specific or movie-specific stuff. So that's going to matter for your homework as to what you can do with an object of type, variable of type rateable that might store a song or a movie, which of course is where we're headed for task 8. But once that method is called, I wanted to just to wrap that one up. But the type of the variable, this will matter on your homework, but not so much on your quiz. So you don't, to be honest, you don't have to think about this too much on your quiz. The type of the variable and whether or not that variable type can call the method, does it know about the method or not? Because we don't give you code on the quizzes, with always the exception of where humans make mistakes do happen sometimes. I don't think it's happened this semester yet. If I might be mistaken on that. But we don't give you code that doesn't compile on the quizzes. So you know that if a method is called through a variable type, you know that it's a legal call. Like, you know you're allowed to do that. So you can assume that this is satisfied on your quiz. But on your quiz, this is going to be the important one. Which method is called? And this is the main thing that we're testing you on next week's quiz, classes 3. This is what we want to see. Aside from remembering all the inheritance stuff, when you have it extends. When you have inheritance, you have multiple constructor calls. If you're calling the super methods, you can call the overridden methods, things like that. But once the method is called, the new thing is which method is called. So even though this use method is called through a variable of type game item, we actually end up getting the weapon's overridden use method. That's the method that's called. So making sure you're calling the right method, that's the big thing for next week's quiz. Are you calling the right method? And we'll see that in action on Wednesday. The roadmap for this week is today's all theory and slides. Wednesday is a big old memory diagram in the slides. And if we have time, some live coding. And then Friday's all live coding. So we're going to get all the theory for polymorphism out there right now. After today, you'll have everything you need to know for the interview. Wednesday will be everything you need for the quiz, and then Friday we'll just reinforce all the topics with some examples. Okay. So why do this? I just said polymorphism is great and spent almost half an hour talking about a downside of polymorphism. Polymorphism is great. Here's a reason. Here's stuff you can't do. It just limits you. So why the hell would we even use this? It seems silly to use it. I'll get to that in a sec. I missed this question. So weapon2.use will call the use method in game item? No. Well, you said that 2 minutes ago after I rambled about it for a while, so maybe I answered it in there. But weapon2.use is going to call the weapon use method. I answered after you asked the question already, without realizing the question was there. So why even use this? The answer is to make other classes better. Because it doesn't really help the weapon class itself, but it can help other classes that use game items. So in our player class, we want our player to be able to use items. Like, we're building out this game. That's the whole point of what we want to build. Our player can use weapons. And I always think of a sword with this weapon class. Probably should have just called it sword. We have the weapon class and the health potion class. We want players to be able to use those things. So we'll have methods in the player class. We'll have two methods, a use weapon method and a use health potion method, which isn't too bad, to be honest. But what happens when we add more items to this game? What happens when we have mana potions, bow and arrows? My brain keeps going there. I went there in the last lecture, I might as well. Molotov cocktails and different types of weapons. We might want like sword, Molotov cocktail, bow and arrow, all extending the weapon class and have more to our inheritance tree. We might have a consumable class. Consumable extends game item. Health potion extends consumable. Mana potion extends consumable. Berserk potion, it's not really a thing in games, but some potion that increases your attack. And for a short time, all those consumable buffs. We might even have passive buffs, things that we can hold that increase certain stats. We might want a lot of game items. Honestly, if we release this game, maybe I spent my summer, built out this game, released it and everything, and there's weapons and health potions only, probably going to end up being a boring game for a lot of reasons. But one reason being it only has 2 game items. So we want more game items. We release our game, and then we start getting feedback from our players, and they say, man, it would really be cool if we had rocket launchers. Oh, yeah, let's add some rocket launchers. We want to expand this game easily. And the player class, I have the player class here, but this would be all over the game. We'll have all kinds of code interacting with each other, and each piece of code would have to know about health potions, Molotov cocktails, mana potions, and everything else, every other game item that we have in our game. We want to code a store where players can shop. We're going to have to hard code all these methods, buy health potion, buy weapon. When we have our physics engine that we're building, okay, physics.move this health potion, physics.move this weapon. All throughout our game, we're going to have to hard code for each one of these types, which is a pain. It'd be absolutely horrible. Programming things, writing code would be very, very difficult. I don't even want to live in that world where we couldn't do this. It'd be very difficult, at least under object-oriented programming. By the way, polymorphism is a solution caused to a problem caused by object-oriented programming and strong typing. Some languages don't even have this problem, and then we don't need polymorphism at all. But this is some way to be able to mix types like this is something we need. So polymorphism is going to solve this for us. Instead, we write one method. Our player class has one use item method that takes a game item. Our shops have one add item method, purchase item method that's going to take game items. Our physics engine is going to take a game item and apply physics to it, do all of the physics stuff, calling that move method to move objects around, detect collisions between objects, all that stuff. We're going to code things to game item, and this is where we start getting the power. This is where we start getting our payoff from polymorphism. Because the code we saw on the other slides, you're never going to do that. You really should never do that. You really should never do that. Where we have game item, weapon equals new weapon. Why would you ever do that? Just store it in a variable type weapon. Why would you ever do anything else? I want the full power. I want all of the methods in my weapon class. I'm going to store it in a weapon variable so I can do everything. So the payoff is when that assignment, that variable assignment, is across a method call. When we're assigning the variable of a parameter to the value of an argument. Now we get to see the payoff. Now we have one method that takes a game item, and I can call this method with health potions, weapons, and any other game item that's going to exist in the future that I haven't even coded yet. This method can handle them. Because it takes game item, it can be called with an argument of any type that extends game item. One method handles every single game item ever that's ever going to exist in this game. So that's our payoff. Now we want to add features to our game. I want to add a new feature, and this is our goal. When I want to add Molotov cocktails to this game, I want to just think, okay, what should this game item do? What should this thing do in my game? Okay, I think when you use it, it gets thrown. and then when it lands, it's going to cause splash damage in that area and affect all any game object that has HP is going to take some damage based on how close it is to the source of the explosion. Like, I want to code that. That's what I'm thinking of, and that's what I want to code when I add that Molotov cocktail. When I add that, I don't want to have to go to my player class. I don't want to have to go to my game world class. I don't want to have to jump all around my code base and add a new method for this Molotov cocktail everywhere where it needs to be interacted with. I don't want to do that. I'm not going to do that. It probably wouldn't be programming if that's what we had to do every time we changed code. What I want is all of those methods all throughout my code to work with generic game items. I'm going to write public class Molotov cocktail extends game item, implement just what Molotov cocktail should do. And if I have code shared across multiple classes, I might think about putting that code in the game item class so they just get that code naturally. And then I'm going to go to my level editor and I'm going to start placing Molotov cocktails throughout my levels that players can pick up and use. That's how simple I want it to be. When I'm writing, just like writing test cases last week, our goal was to make it as simple as possible. When I add a new test case, I want to add the input, I want to add the expected output, and everything else is shared code across my test cases. I don't want to think of anything else except the bare minimum of what I have to think about. Same thing here. This is a general approach to all of programming. I only want to have to think about what I have to think about. I don't want to think about any extra overhead, because programming is hard enough as it is. If every time we're adding an item to this game, we have to jump around our code and edit all kinds of things and constantly remember, okay, where else do I have game items being used? And then risk forgetting one time. Maybe I forgot to add Molotov cocktails to my physics engine, and now my physics engine doesn't work with Molotov cocktails. And then my game's buggy and broken. I don't want to have to do that. It's way too mentally taxing. I want to set up the infrastructure, the architecture, in a way that's very easy to add that new game item. So now the payoff's worth it. So yes, in this method, I can only access methods known to the game item class, but it's worth it to only have to write one method for any game item ever. And there's more. So there's two big payoffs. That was one of them. The general, if an object is a type, it can be treated as that type. Storing it in variables of that type. Okay, one was doing that across method calls was very useful. But two, we can do this with data structures too. This is also extremely helpful. So say I want my player to have some inventory of items, and I don't want array list of weapon, array list of health potion, array list of bow and arrow, array list of Molotov cocktail. I don't want to have to do that. Array list of armor. I'm not doing all that. And then checking, if you're at your maximum inventory, you have to go through all those array lists and sum up all the weight or however you're doing it in your game. Things would get extremely messy very fast. And then displaying that to the user. How do you display that to the user when you have 10 different array lists containing all the inventory? No, I want one inventory of game item, and that's it. So if the generic type of our data structure is a supertype, then anything that extends that type can be stored in that data structure. So we're finally getting a feature that we really took for granted last semester in CSE 115, where JavaScript and Python were like, oh, you want Python specifically, because I'm about to say list. You want a list of that has an int, a double, a dictionary, a player object, and a beach ball all in it? Yeah, whatever. Python and JavaScript are like, yeah, anything goes. You just throw anything in your data structures. It's cool. No worries. JavaScript, not so much. All year, all semester, we said, okay, we have to have this generic type. And if you have an array list of integer, it can only ever store integers. If you have an array list of players, it can only ever store players. You want an array list of Molotov cocktails, it can only ever store Molotov cocktails. We're finally bending that one a little bit too and getting a little more flexibility here. If we have an array list of game item, it can only ever store game item. But guess what? Health potions and weapons are both game items. So this array list can store both of them. If I have an array list of rateable, it can only ever store ratables. But guess what? Songs and movies are both ratables. So that array list can mix those two values, those two types. So we finally have array lists, data structures that store multiple different types in them in a strongly typed language like Java. And yes, my phone fell asleep, so I had to check. It usually comes up in chat. Yes, you can have an array list of object that can just store anything except primitives, but generally it's not super useful. So again, if you have your variables of type object, you can only do object things to it, like toString and dot equals. So it's just not generally useful to have an array list of object. It is legal, it's valid JavaScript, and you can do type checking. Like there are things you can do to actually make that useful. You can check the type and then do something different based on the type of the object that you have, and then convert it to the appropriate type. And there's things you can do. For example, the equals method does take a parameter of type object. And then each equals method, you check the type. If it's the right type, then you do different things to it. You can typecast it and things like that. It's a little messy. It's not too crazy. But it's messy enough that we never talked about overriding the equals method in this class. Because then we got to talk about checking all the types and stuff. So you can do it, and in some cases it is useful. But generally, it's not super useful. We want to do game item stuff. For the homework, we want an array list, not to just give it away, but hopefully you can all see where that far at least, of where this is going. You have an array list of ratables that can store songs and movies in it. And then since they're ratables, you can get the title, and you can do all the rating stuff. You can add ratings to it. You can get all the ratings. You can get the Bayesian average rating, which is how we're going to generate our top K lists. We're going to use the Bayesian average with 2 ratings of 3. That's why we set that up way back when. Bayesian average of 2 ratings of 3, that's going to be used for our top K method. And then that's how we're going to get our top K lists. We can do that because song and movie both extend rateable, and rateable has all of that ratings stuff, the ratings linked lists, the Bayesian average method, all that stuff is in the rateable class ever since task 5. And now we get to use that to mix these types. We actually got here a little faster than the other lecture. I think I talked faster. Any questions? We might go a few more slides, and then, but I might back up to the abstract stuff on Wednesday. You know what? Maybe I will just finish up the slides. Maybe I won't revisit these on Wednesday, but I have to remember where I stopped in each lecture. So anyone who has done OOP in Java before CSE 116, when I was talking about inheritance, you were probably wondering, hey, where's the abstract methods, the abstract classes, and the interface, and the implements? Where is all that stuff? What the crap? Well, we were saving it for Polymorphism week. When it's just inheritance that we're talking about, it doesn't really make sense to use abstract classes or any of this, what we're about to talk about. But once you have polymorphism, we get to see some benefit to abstract classes and abstract methods and all the like. So we can make methods abstract. An abstract method, we use the keyword abstract and define the signature of the method, which is the name, the parameter list, including types, and the return type. And then we don't implement a body. We don't implement the method definition. We just close it with a semicolon and say, that's it. What this means is that this method will exist, but it doesn't quite exist yet. If you have any abstract methods, your class itself has to be abstract. And if you have an abstract class, you cannot create instances of that class. You cannot say, now that this is an abstract class instead of a regular class, you cannot say new game item. It's not allowed. You can't call the constructor of an abstract class. You can never create an object of type game item. And the reason for that is, say I said new game item, say I said game item equals new game item of 0, 0, just 0, 0. And then I did item.use. What should happen? What would happen if I called an abstract method with no definition? I don't know. Java doesn't know. And Java doesn't know to the point where it's going to say you can't do that. You can't create an object of an abstract type. This abstract class only exists to be extended. So you have to extend it and then create objects of the subtypes. And that's the only way you can use this class at all. It just exists for inheritance and polymorphism by extension. So once something extends game item, it has an obligation to implement every abstract method. It has to override this use method, every abstract method, give it a definition, and say this is what happens when the use method is called on this objects of this type. So there's no method that's inherited and then overridden. We're just implementing the method for the first time. So we're overriding no definition with a definition. The subclass has to implement all abstract methods. If it doesn't, it itself has to be abstract. And then it's just passing the buck to some other class that's going to implement those methods. So why do this at all? Why would we ever use an abstract method? Well, so far we haven't, and our lives have been fine with no abstract methods. So the reason to use these is when you want to call a method using polymorphism. We have our player class that has a method that takes a game item, and then we want to call the use method on those items. So I want to call it on every object of this type, every object that extends this type. So the abstract method gives me a guarantee that that method does exist and that the game item class knows about it. So now my variables of type game item, I can call the use method, even though the game item doesn't care what the use method does. It doesn't even bother implementing it. So more specifically, when we don't want any default behavior, when we say you have to implement this and do something, but I'm not giving you any default behavior. When we had these situations before today, we would just say use equals open brace, close brace, and just have it do nothing as the default behavior. But if you don't want default behavior and you want to force your subclasses to implement it, just make it abstract and say you got to implement it. I don't think the music's going to